So welcome to the third tutorial. This one's going to be very short, but I do want to touch well, on explain a little more about GeoDraw arrays. And this tutorial, we're simply going to extend our dot into a full triangle, but I really do want to talk about what GL arrays does here. So when we make the call to draw the geometry, all the commands that we've seen so far are important, but they only set the stage for the draw command. This is where the GPU really starts to work, right here on this line. It will now combine the parameters of the draw call with the state that was built up to this point and render the results to the screen. OpenGL provides several types of draw calls, and each one is appropriate for a different case. In general, you can divide them up into two categories: ordered draws and indexed draws. Ordered draws are simpler. The GPU traverses your vertex buffer, going through the vertices one by one and interprets them accordingly to the topology specified in the draw call. For example, if you specify GL triangles, then vertices 0 to 2 become the first triangle and 3 to 5 the second, etc. If you want the same vertex to appear in more than one triangle, you will need to specify it twice in the vertex buffer, which is a huge waste of space. Index draws are more complex and involve an additional buffer that is called the index buffer. The index buffer contains indices of the vertices in the vertex buffer. The GPU can scan the index buffer, and in a similar fashion to the description above, indices 0 to 2 become the first triangle, and so on. If you want the same vertex in the two triangles, if you want the same vertex in two triangles, simply specify its index twice in the index buffer. The vertex buffer needs only to contain one copy. Index draws are more common in games because most models are created from triangles that represent some surface: skin of a person, castle, wall, ground plane, etc., with a lot of vertices sharing between them. In the previous tutorial, we used the simplest draw call, GeoDraw arrays. This is an ordered draw, so in that tutorial, it was an ordered draw, so there was no index buffer. We specified the topology as points, which meant every vertex was a single point. The next parameter is the index of the first vertex to draw. In that case, we wanted to start at the beginning of the buffer, so we specified 0. But this enables us to store multiple models in the same buffer and then select one to draw based on its offset in the buffer. The last parameter in this case is the number of vertices to draw. In this tutorial, we are still going to use GeoDraw arrays. We are just going to extend this to 3 vertices and draw a triangle. This could be done by increasing this to 3, specifying remember, these are normalized values. And all we have to do is change this to 3, to draw 3. And now I'm going to explain to you what these numbers mean, because they're not entirely obvious. So, what you get is a box, essentially. Think of it as a giant box, which I'm drawing out here. Actually, I'm going to use a program called, I'm going to use just typical paint. So, consider you have a box, and this box could be separated by 4 quadrants or regions. The point up here is referred to as minus. Actually, probably better to use text. The point up here is referred to as minus 1.0, 1.0. The point over here is referred to as 1.0, 1.0. The point down here is referred to as minus 1.0, minus 1.0. And the point over here is referred to as 1.0, minus 1.0. Okay? So if you want to draw a triangle, minus 1.0, minus 1.0 specifies this here, specifies this point. 1.0 minus 1.0 specifies this point. And then finally, 0.0, 1.0 is going to specify this point. We're not going to, remember we have 3 points, 3 vertices. So 0.0, 1.0 is going to specify within this region. So remember we have increments. So this should draw a triangle. And it doesn't. So let's see what went wrong. Maybe it's because I'm still drawing it as points, when we should be drawing it as a triangle primitive. And there you go. There is our triangle. And that concludes this video tutorial.